I don't forget. All right, so let's get started. I'm going to share my screen. All righty, so to get started, we're going to be talking about some basic graphs. If we have time, we'll go on to cover some other ones. And then we'll talk about the translations for each of these. So are you guys familiar with the graphing here in the Cartesian plane? You all have experience with that?
Yeah.
All right. So hopefully we all know what the first one here is y equals mx plus b, right? We've all seen that before. M here is going to be the slope of the graph, and b here is going to be the y-intercept, where the graph intersects the y-axis, right? Are you all familiar with this? Just a quick review before we get on with the other stuff. All good. Is Lloyd joined in audio? Not yet. Okay. All right, so let's talk about how to do some translations for this y equals mx plus b function. So for example, I have a function f of x. Let's call it 2x plus 1 here for now. I'll hide this line. All right. To move this function up and down, we can pretty clearly see that we're just gonna define new function here. So to move this function up and down, what can we do here to f of x, here in g of x? We want to move g of x, let's say, up 2 units. We can just add 2 directly to that, right? So for every value of f of x, we're going to add 2 to it, which is going to lift all the points on this line here up. So that's going to raise our graph. Now got that? All right, so now let's think about how we can move this left or right. You guys have any ideas? I'm going to move the black line here, g of x, left or right. Ideas? All right, so what we're going to do is actually change the x inside f of x here, right? So we're going to change all of our inputs to give to this function. So let's say I'm going to move it to the right, do f of x minus 2 plus 2. As you can see here now, our black graph is moved over. And just to show that, we can do another function here. That. So we have the red line here, which is moved up 2 units. We have the black line here, which is moved right. These change here. All right. So for every,
can I ask,
sorry?
why do you minus 2 and then add 2? Wouldn't it just like cancel it out?
Yeah. So the difference here is you see the minus 2 is inside the f of x, right? The difference
Okay.
here is when we add 2, what it's doing is it's getting our output, right? So for every value that we give into g of x here, let's draw a point. Let's do the point, let's say 1, 3, 1, 1, 3. So you see that blue point here, right? So when we feed in x equals 1 to g of x, it'll pass that x into here. So essentially this x goes to here, goes to f of 1 plus 2, right? And what is f of 1? F of 1 is going to be 2 times 1 plus 1, right? 3. As you can see, that's where it is on our purple line. And then we're adding 2 to that. So if I zoom out, you can see 0.15. We're getting an output from f of x for that input, and then we're adding 2 to it, which raises it up 2. Right? Because again, f of x here, this is the y value, and we give n x value as input. So that's why when we add 2 outside the function, it'll move it up. All right, now I'm going to get rid of this plus 2 here, and we're going to add 2 inside the function. And I'll hide this red line now. So let's explore what happens here, right? Before we add in that 2, before we add the 2 in, it's still the same. So you add 2, as you can see, this black line here is moved left 2. All right, so why does it do that? Let's think about what's happening to the x as we input it. So again, we'll go back to the blue point here. So for g of 1, it's going to be f of 1 plus 2. All right, so what we've essentially been doing is for every input, we've change the input to add 2 to it, right? So originally, f of 1 is going to give us 3. That's still this blue point here. But now instead of doing f of 3 for f of 1 for g of 1, it's going to be f of 3 because we added 2 to that input. All right, so now that input is going to become f of 3, which is going to give us output of 7. So we go 1, 7. Here you can see that point. All right, what this essentially does is, even though it looks like it's higher up here, what you're doing by adding this here is you're shifting the function left and right. So if you add 2, it'll shift the function to the left. -2, it'll go to the right. All right, so with those two, that's just basic translations. Translations is when we're moving this graph around without changing it. And we can move it up and down. All right, so that makes sense, everyone? Joyce, you with us? I don't think Loy is still connected. Let me message him in the chat real quick. All right, so let's move on to the next function here. We'll come back. We'll go over translations for all of these. I'm going to clear the Desmos. All right, let's talk about the second type of function, which is going to be quadratics. All right, the third one here. So you see, instead of a straight line here, we have a quadratic function, right? So let's break down each section of this quadratic function, starting with just ax squared. So let's do one, y equals x squared. So what is it doing here? You see it's a curve, right? Instead of growing linearly, like the y equals mx plus b, where the line is a straight line going up, this is x squared, right? So for every increase in x, y is not going to increase the same amount, right? As x increases, y is going to start increasing faster than x, which is why you get this curve, right? So you can see if I add a... And to change this, as you can see, the ax here can multiply this by some number, let's say 2, right? And that'll shift everything closer together. What's happening here is, again, for every single x value, find this as fx. For every x value that's coming in, we're doubling the output, right? We're going to first square the x and then double it. So compared to the original, which is x squared. So you can see how the green one is sort of skinnier than the red line here.
What if you what if you x multiplied by x? Would it like just make a straight line?
Which part? For the green function for f of
Yeah,
x?
for the green function. If you change the 2 into the x number, yeah, x times x, it'd probably make a line, right?
No, as you can see here, this is,
Oh.
yeah, we have a little bit of more of an interesting relationship going. We can explore that later on. Keep that thought, but for now, let's keep going over just having whole numbers here, right? I'm going to stick with the x squared to talk about quadratics. But good question. We'll touch on that if we have the time later. All right, so you've gone over what the a value does for this, right? And now going back to what we learned earlier with the translations for y equals mx plus b, how can you move this function over? So if I define g of x is f of x, how can you move this function, let's say, up and down? What should we do to this right here? Can you remember? All right, remember, for every single output of this, we want to either move it up or down. So we're going to add or subtract a number, right? So to move it up, like I can say we're going to +1. To move it down, we do minus. Right? All right, going back to what we learned earlier again, how can we shift this function left or right? Guys with us?
I miss a lot of class. I don't get it.
Oh, okay. Don't worry, we'll go back to the other explanation. Let's just define this easy function. y f of x, so just call f of x equals x for now, right? Let's go back to translations, go over it a little bit more. Oh. So to move this, now what I'm doing by calling g of x f of x is we're defining this new function as this function, right? So we can make changes to this function right now. We just call it, another line here, erase that. Okay. So we're not doing doing any changes to f of x, right? So g of x is equal to f of x. These two are the same thing, as you can see here, right? So when I hide the green line, you can see that they're the exact same function. But I can start making changes to f of x. I can multiply it by some number. I can add to it. I can even change the input, right? And what we're doing here is changing f of x to define g of x. Okay, so all these changes we'll go over. All right, so going back to basic translations, right? Moving this green line up, down, or left or right. So if we're
So
moving
it's
the
at
green
1
line,
and -1, right?
yeah. So remember, this line is created by giving all of the x values, right? And for every x value that we give it, which is the input here, we're going to get an output. Okay, so what we're doing is the original function had the point 1, and with a new translated function, we're going to have the point 1, 3. Because for that same input, x equals 1, we gave it f of 1, which is equal to 1, and then we added 2 to that value. And this is the same for all points on that line, which is why it's shifted up. Right, and then moving this left and right, let's go to the +2 and instead move it inside the function. What are we doing now? We're not adding the function after it, we're changing our input for that function. So where for f of 1, if you gave f of 1, it would be equal to 1, right? X equals x, f of 1 equals to 1. But for g of x, when we're changing the input, we're going to get f of 1 plus 2, right? So rather than giving it f of 1, we're giving f of 3. And when we're going back up here, what is f of 3? It's going to be equal to 3. So when you gave it 1, instead of outputting 1 like the original function here, it outputted 3 because we're adding 2. All right, so if I make this follow the mx plus b form, let's do 1/2 x, so it's a little bit better in our screen. So you can see as I shift this value, move it around. 3. You see that, how we're moving it left and right. Does that make sense? We're
What
changing,
if you do a decimal, like 2.5?
yeah, that would still work. You're just changing it
Oh,
by not a whole number amount. All right, so now we understand the translations for all these functions. Let's go back to trying to translate that quadratic function. Clear some of these lines. All right, so we have our quadratic function, x squared. So first of all, let's break down what this function is doing, right? For every input, our output is going to be that input squared. So I give it f of 2, the output is going to be 4 because we have 2 squared, which is 2 times 2. I'm multiplying it 2 times 2. I'm multiplying it by itself. All right. So as x changes, as x increases here, the y value is going to increase faster because it's going to be the x value squared. So that's why you get that curve here. All right, so we have f of x defined as x squared. Let's try to do some transformations to g of x, which we start off with f of x. All right, so we still remember moving it up and down, very easy. If we want to change that, we can just add or subtract a value, right? So you push it up. And then to move it left or right, we change the input. If we minus something, it'll go to the right. P plus something, it'll go to the left. If I zoom out here, you see that these are actually the same functions. They're just shifted over. Does that make sense? All right. Now let's go over trying to change the function by stretching or shrinking it. So going back to the mx plus b example, let's go back to our line example. What do you think will happen if I graph this? 2 of f of x.
Is it gonna make two lines in the same place?
No, right? Doing here is f of x is the output, right? For the given of input of x, f of x is going to be the output. And what we're doing is we're multiplying that output by 2. So let's reveal this. As you can
So it's gonna
see,
be twice the output.
yes, exactly. So as you can see, it sort of looks like that line has been tilted up more, right? The original line here is the purple line, the red line here is sort of tilted up. So let's explore that. For a point here, let's say 2, 2, which is on the function f of x equals x, right? And what's doing here for g of x is it becomes, instead of 2, 2, it's going to be 2, 4. We give the same input. That input from here will go into f of x, and f of x will give us 2. And then we're doubling that, which gives us 4, right? And you can see this continued in 3, 6, 4, 8. So if you just have a function that doubles the input, what would that function look like? Let's write it here. What have we effectively done with g of x? What does it become? We're just doubling our input. Our input is x. Any ideas? It's going to be 2x, right? So we give it an input of x, it's going to double it, which is going to be x multiplied by 2. So here you can see that these two are the same thing. If I hide the red line, you sort of see that these are the same lines. All right, so does that make sense here? We're just doubling the output. And if I do some translation, let's say, let's move the purple line up. This is still going to be doubled. See, every single point vertically is doubled. So here's 1, 3, it's going to be 1, 6. If I find 2, 4, it's going to be 2, 8. Okay, so whatever happens here, it's doubled. All right. So if I change this 2 to, let's say, 0.5, what do you think is going to happen to the function?
Half of it.
It's half of it, right? We're halving all the inputs. So is that line going to be tilted more or tilted less?
Less.
Yeah, there you go. Right, and again, 0.5 f of x is the same thing as changing this to 1/2 x. So you can sort of see the relationship we're doing here going back into the original function. All right. So let's explore how that changes the quadratic function. Clear the Desmos a little bit. All right, still the same thing. G of x is equal to f of x. Right? If I put this to 2, it's going to double all of our outputs. Right? So what is that going to do? It's going to stretch the function this way because everything is going to be double, or it's going to look shrinked. Right, so I put 2 here, so you can see, there you go. That red line here, or you make it more obvious, let's say 4. It's skinnier than the purple line, purple curve. And after doing these changes, we can still do all the same translations that we did earlier. That we can move it around, still gonna be the same.
What if you set the times into like 16. Would it
times,
like flip backwards?
no,
Like
the great,
16f.
16f, yeah. So right now what we're doing is we're multiplying it by 4, right? So we change it to 16, it's gonna be 16 times. It's gonna look really stretched. So
Yeah, so would it eventually become a line if you did like 125?
it'll look close, right? We can do really large
Uh,
numbers. We'll get skinnier and skinnier. But until we approach infinity, that won't become a line. So we can do really large numbers. That looks
oh,
like it's almost a line. But if you zoom in, you can see that it's still a curve. Because all you're doing is just
oh.
multiplying by such a large value, it becomes really stretched out. Yeah, but good question. All right, so Lloyd, Joyce, are we all on the same page here? If you guys are confused on anything, I go back and touch on. Oh, some chat. All good? All right. Um, so now we've explored how these functions are affecting we have the x function defined here, and we have g of x is equal to x, right? So how do these go back to changing the original function? Now let's do some practice here. Have a function x squared, and then my g of x is going to be, let's say, 2 of x fx minus 1. Right, so what curve or what function will this be? Right, without using f of x, how can you find this? So we're trying to visualize what these changes, we're trying to understand what these changes here externally are doing to the function internal. So what do you think this g of x function would be if you wrote it without using f of x? Any guesses? All right, don't worry. So let's think about the first one. We're going to start off obviously with the x squared, right? Because that's what f of x is. We're multiplying all the outputs of x squared by 2, right? That's from the 2 of fx here. So you can do is multiply this by 2. And then what we're doing is we're subtracting every single one of these by 1, right? Effectively shifting it down. So here we add a -1, and then we'll see that these two functions are exactly the same. All right, cool. Does that make sense? Sort of see how these changes are actually going into the functions. All right, let's do another example. This time, let's go with just 2x here. Do the same thing. Say 4 of f of x plus 5. Right, so what function can you write here to define g of x?
4x and then plus 5.
All right,
Oh
so
no.
it's not quite, you see, you're close on the right track. Your y-intercept here is the same. What's the difference here? So your original
Oh,
function
so
is,
2x times 4 plus 5.
yeah, 2x times 4, which is what? Same thing as
8x.
8x. There you go. All right, so if you write 8x plus 5, we can see it matches up exactly. All right. Let's do last one. Say 6x squared. Do the same changes, or do some different changes. All right, so what would our y equals here? How can you define g of x without the f of x?
I'm just guessing, is it 6x to the power of 2 times 1/2 plus 6?
Exactly, and then what's 6x squared times 1/2? Same thing as,
3x. No. 36. I don't know.
So the original function is 6x squared, right? So we have 1/2 times the 6x squared. So what we're doing here is changing 1/2 times 6 into 3. So you get 3x squared. So very close. And then you're right, we add 6 to the end, and once we reveal this, you'll see that it's the same one. Yeah, good job.
Why is the purple line thicker?
Oh, it's just what the graphing calculator does. When it has two lines overlaid, it'll sort of make it thicker. But yeah, they're the same curves. All right, 1 sec. 2. Oh, sorry, wait, screen. Sorry. All right. So now let's take a look at what we do to change these intercepts here, the slopes. Right, we know that when we multiply this function, let's cut off a few here. We multiply this function by 1/2. What we're doing is we're cutting all the outputs by half, right? So what is that doing to the slope? Oh, sorry, I should go to an 6x here. What is that doing to the slope here? Right, we're directly cutting the slope in half for this. All right, so we've covered all that. Let's see. All right, now let's introduce another here, which is going to be absolute value. So we can explore how this changes functions. So let's say we have a function y of x, it'll be this red line here going up. But if I add this absolute value thing here, you can see what we get is a sort of V shape. Right, so based off this, what do you guys think this absolute value is doing?
Does it make it like from a negative to a positive?
Exactly what it's doing, right? So you can see, we look down here between this red line and this blue line, all it's doing is getting these negative values and changing them to positive values.
So if you did, oh, okay.
Yeah, so you're exactly right. So if we do some transformations to this, what do you think is going to happen? All right, let's say 2 of f of x. Remember, our original function is going to be this. What do you think this is going to do to that?
2 times the output.
Mm-hmm.
And
So what would that do to the graph shape? You're exactly right. It's going to multiply the output by 2.
would it make like a W?
No, not quite. So let's take a look. Right, with 2 times the output, every single output here is raised up. So that gives us a larger slope, right, for these lines. Does that make sense?
Yes.
All right. So, it's pretty much all we had planned for the transformations. We got through that a little bit faster than I thought we were. So, since it's been a while since we have done puzzles, let's go over this. But before we end that section, does everyone get what we went over today? So we went over the basic, what can I ask? Y equals mx plus b functions. Went over basic quadratic, right? What it does to x squared. We explore what we can do to stretch and shrink these functions, as well as what we can do to translate them around. So are you all good with that? Choice is okay. Kimi, you got any questions?
No.
No. All right. So let's go to this. I'm gonna send this link in the chat.
Can we do like the old thing where we did like the move the rings so they're stacked up?
You want to do Towers of Hanoi?
Yeah, that I like that game.
Sure. So we'll take a quick look at some of the geometric transformations, and then we'll go do some tower of Hanoi. All right. So first of all, what are these geometric constructions, right? So the goal here is to do some of these challenges on the side, so help you gain a better understanding of geometry. And the rules are that you can only draw circles from one point to the other, right? So you can define the radius of circles, the difference between these 2 points. And you can only draw lines between 2 points or intersections. I mean, you get 2 starting lines. So I'm going to go over how we can build this triangle. Then we're going to try to do the hexagon and the circle pack 2. So first of all, when we want to draw a triangle, we want to have 3 points, right? And right now we have 2, so we have to create that third point somehow. So we're going to start off with a circle here, and then draw a circle here, right? And now what have we done with these 2 circles? We've created 2 new intersection points, right? And with these intersection points, we can connect them to draw our triangle. So this is a perfect equilateral triangle. So why do you guys think that is?
Because because it's made out of circles. And also the circles are overlapping perfectly in half.
Exactly, right? So these are the same radius for the circle, which is why you have the equilateral triangle. So here you can see how to build the triangle. All right, so now I'm going to send link here, or the meeting link, sorry. This puzzle link into the chat so you can take a look at that. Let's try to build the hexagon, right? Using pretty similar idea to the triangle. Let's try to build the hexagon. So let's take probably 2 to 3 minutes. Again, don't worry about messing up. If you ever mess up, you can press the undo buttons here. It's just be Z to undo. If you want to reset, you can press X. So let's take probably 2 to 3 minutes. Just try out making the hexagon. And then we'll go over it. All right, so it's been a few minutes. Has anyone gotten to the hexagon? And again, no worries if you guys didn't finish. Hopefully you had a chance to try out the puzzle.
I think I got like the first few steps. I got like the first 2 moves, but I didn't know what to do after it.
No worries. You want to describe what your moves were so you can try to build off your progress.
Yeah, I just did like a basic thing, and then I used the top to make it like a 4 circle
Up to here or to the middle?
to the middle. That made me 3 more. I mean, 4 more points. I used each of their points to make another circle.
Which point? This one?
Each of the 4 points, yeah, the new 4 points that you made.
What are points there? Like that?
And then, yeah, and then you should be able to make the hexagon.
Yeah, so you see all the 6 points, right? You got it. All 6 points right here. We connect them up. And there's your hexagon. Yeah, good job. There you go. That was an 11 move hexagon. So really good. You got under the first barrier. 14 moves or less. All right. Let's try another challenge. This is going to be the circle back 2. So for this one, what you want to do is to have 2 circles within a larger circle. So you can see here where my mouse is. You have those 2 circles touching each other in a larger circle. So let's take probably another 3 to 4 minutes and try out that puzzle. All right, so how are you guys doing? Do you need a few more minutes for the puzzle? Or are you completely stuck or you're almost there?
I'm almost there. I don't know what to do.
No worries. You want to take like maybe another minute so you can figure it out?
I don't really get it now. Like, I got the 2 huge circles. Oh no, it's supposed to be only 1 huge circle? Then I don't know what to do.
No worries. You want to talk me through what you've gone so far? We can take a look at.
So I
we can-
first got like the 2 circle thing that you usually do
Mhm.
every time you start one of these puzzles. And then I did like this the another 2 on top and on the bottom. Give me 1 second. So now I just did a even bigger circle around them.
From this point?
Yeah. I mean, no, not from. Wait, what? How did you make that? No, I mean, like, I did like the 4 circles. Like, can you reset it?
No problem.
So like I first did like the double circles from one point to the other. And then I did from the top, yes, in. No, not to the big one, to like the middle one. And then both of them to the middle one. And then I got to trying to get the big circle by using by going from one corner to the
Like this?
no, but like the top left corner all the way down to the bottom left corner.
Oh, like here.
Yeah, that would make like a huge circle.
Yeah, that gives you your intersection point in the middle, but you don't really have an intersection point on the outside. And also, these two circles are not touching on the edges. They're not tangent to each other. But that's a really good attempt. So let's take a look at another solution to this. So try to draw it out. So what we want is a larger circle and then quarter radiuses for the circle. So, oh, wait. Sorry, I don't think doing this correct either. I think that was, no, it's not the point. Oh, let me see if I remember this. I get a larger circle and then surround all the insets. So there's one of the middle circles. Now we're going to create a second one. Should be done. So we have one of the circles in the middle. I want to get to another point somewhere over here before I can draw a line to connect that. So I think the method might be to... It's actually kind of hard. I don't think I'm solving it either.
I think I think it was like you draw like a circle to. Oh no, never mind.
So I don't think there's a way to get over here to this side based off what we have. I went to do a circle like this. Hopefully that will make things a bit different. Yeah, this is a good puzzle for my brain. Maybe get over here.
Oh,
So I think there's definitely some other solutions, but this is one of them.
dang.
So getting over there, a lot of circles may not have been the best move. As you can see, that was
Can you do the pentagon?
7 moves, but we're not in 5 moves or less. So there's
Can
definitely
you do the
room.
pentagon?
Pentagon?
Uh huh.
Oh, that looks like a really difficult one. You guys want to give it a
Yeah.
shot?
No, I just like to watch people get it.
All right. Well, I'm not sure if I can get the pentagon either, but we'll see. Um, Pentagon. Dang. It's gonna be tough. Yeah, that's not Pentagon. So for Pentagon, we need five. Five different points around that circle. That's gonna be pretty hard. Let's take a look. We're probably gonna need a lot of helping lines to get there. Look at the pen. Let's go down to here. And from here, it's definitely not it. Yeah.
Can it be a hexagon?
Yeah, this is not the correct approach. Let's see. Maybe we should.
It even says 21 to 15 moves.
So you know it's gonna be pretty hard, but I think it's worth
It's
taking it.
probably not as hard as a decagon.
There's a decagon?
Yeah,
Oh,
26 to 20 moves.
oh. Yeah, that's gonna be a messy one. But let's see, do you have any ideas for this?
No.
It's okay, I don't either. Let me think. Start by drawing what I have, and we'll see if it works out. Keep on making hexagons. So I think I've accidentally made another hexagon. That's not gonna be. So maybe there's some method to get that on. So need the point around here. Well, we got 10 minutes in today's lesson. I don't think I can figure this out in 10 minutes. Do you guys want to keep on trying this puzzle, or do you guys want to try some Power of Hanoi before we finish? I think I might have the start to a potential pentagon in here. Maybe there's a method to get some more contact points there.
I got the triangle in an orange or Oregon circle.
No, it's not quite a pentagon.
That is
Oh,
a pentagon though.
well, the angles are not quite right. I think it's a sort of
Oh.
smushed pentagon where I sort of started with something else and then sort of make it look like one. But sorry, which one did you get?
I got the triangle in an origin circle.
Oh, triangle and origin circle. Nice. How many moves is that?
Like 12.
Oh, nice. But well, these puzzles are pretty fun, and but again, the goal of all these constructions is to help you better understand the relationship between a bunch of these circles and lines. And eventually, practicing all these constructions will help you get better at geometry because you're going to start to see those relationships when you're doing those problems. As for the Pentagon, I think I'm stumped for now.
There's 8 minutes left of class. Can we go to like the
You know,
stack the thingies?
sure, let's try Towers of Hanoi. Towers. So it's been a very long while since we've done this. So do you guys still think we remember? Let's start off with just 3 discs and we can move on to a pretty large puzzle. And the goal here is to find that pattern, that recursive pattern for solving this.
I honestly kind of forgot the rules and what you're supposed to try to achieve.
Yeah, so we're trying to move all of this onto this side, right? And the rules, you can't stack anything larger
Um,
on top of anything smaller. So we want to, let's take a look at solving the 3 disc. So what we want to do is move this over here. We can sort of arrange it to solve the puzzle, right? So that's sort of like an example of how you do the Towers of Hanoi. So let's try
whoa.
5 disc, right? So overall, pretty similar, but the goal is to find, again, find that pattern for how we can solve it.
Maybe
So this one here, sure.
that.
And then we can't place this one on top of here, right? So the
Yeah,
only place we can go is
yeah. And then you move this one on top of there.
that opens up here.
Yeah. And then you move this one over here. Move this over here. And then move that back. Put the yellow over there.
All right.
And
So
then
if
put
we
everything. Put this one over here. And then put that one on top of this yellow thing. And then put the small one on top. And then move that one to the big yellow. And then take that off. I mean, no, put it over here. In the. Yeah, and then put that over there. Put the yellow over there. Yep, and then put the purple. And then move the small one over here. And then the green one up here. And then move the green one back.
All right, so we're very close, but at this point, you
Dang.
might notice a small problem. Again, I guess this still counts as solving it, but the goal is for this whole tower to be on this last stack over
Oh,
here.
yeah, yeah.
Current when we put it here, right? So again, it's kind of similar to the 3 discs, right? Remember the 3 discs? The first thing we did was we moved it all the way to the right. But again, we'll just continue because moving it to the different towers will pretty much the same thing. So yeah, anything we can finish this off. And keep going. So goals to rearrange all this somehow. This first 3 somewhere else, so we can unreveal. So we reveal that 4th disc. All right, so we can move that 3rd disc over, the 4th disc on. And how do you think we can finish this off? Again, we have a little bit of extra moves. The goal is to do 31, but I did some extra misinputs, so move counts a bit off. All right, how can we finish this off? Just got the 3 discs left.
And then you put the this one over here. This one over here. This one over here.
Oh,
Oh
here.
yeah, yeah, over there. And then you move this one over here. I know that's completely unnecessary, but I like it on the right. Move that one over here. move. I'm stumped.
It's okay. Is there a way I can go
Wait,
back?
oh, I know. Go over here, and then put the small one on top. That one over there. Put the small one on top, and then yeah,
And
finish
then you
that.
got it. Few hiccups, 42 moves, nothing that can't be solved the second attempt. But yeah. So again, remembering the pattern. We did go over this last it's been a few years actually. It might have been a year since we last went over Towers of Hanoi. But again, it's that recursive pattern that just keeps building. So eventually do 8 discs. Even that to be a bit repetitive, 255 moves, but overall the same thing. All right. So to recap on what we did today, again, going over the mx plus speed and the exponential form, as well as the translations that we're doing, right? The important takeaway for this is to learn that the function here is just a set of inputs and outputs, right? And as we change this function here, all we're doing is modifying either what it outputs, it'll give us a certain number, we can change that, or we can change what number we feed to that function to give us a different output. And with those simple transformations, we learned how to stretch, squish, and then move around those functions. So that's it for today. Sorry about starting at 7:30, but hopefully that wasn't too much of an inconvenience for you guys. Good job. So
Thank you.
yeah, next class we'll probably do a quick review of this, and then we'll move on to some other fun graphical stuff. All right, guys. Good job today.
Bye. Thank you.
Yep, have a good one. Bye.